So, the one rule that you need to know when adding and subtracting radical expressions is you can only add or subtract like radicals. What in the world is a like radical? It's just like terms. Like, you know how you can add, so let's just, so recall. What's 2x plus 7x? 9x, right? Because, and I can add them together because they have the same variable raised to the same degree. We call those like terms, right? Same way if I wanted to do like, I don't know, 5x to the third minus 2x to the third, I would get out, what? 3x to the third. So radicals work the exact same way. As long as I have the same radical, I'm going to add or subtract the coefficients. So what's a like radical? Something like this. If I had 2 root 3 plus 6 root 3. So they both have this root 3 on them. So as long as they're the same, it's really saying I have 2 of these things and 6 of these things. So altogether, doesn't that give me 8 of these things? So see how the root 3 doesn't change. Same way, it didn't change up here. When it was 2x plus 7x, I just got 9x. 2 of these and 7 of these is 9 of these. Same thing here. So nothing changes. 2 of these, 6 of these, 8 of these.
For number 1, would it just be -1?
That's it. So if you look at number 1, you have like radicals. They're both root 6. So I'm really just doing 3 minus 4, which is -1. So I get negative root 6 as my answer. That's it. So jump to number 5. Yep.
Okay, so when you write it out, you just write the negative. That goes 1.
Oh, yeah. Right. So you can write the 1 there if you want to, but you don't have to. If it's a 1, you can just write the negative sign. How about 5? Negative 10 root 7 plus 12 root 7 is just going to get you 2 root 7. That's it. So, Ms. Sabia, this is so easy. Why are we even bothering? Well, sometimes you have like radicals and you don't know it. They're hiding. So, for example, if we look at number, I don't want to do that one yet. 9's fine. If we look at number 9, at first glance, these do not appear to be like radicals. But, yeah, they actually are, because, what's going on?
The 24.
Yeah, that's not simplified, right? The square root of 24 has a perfect square factor, so I can actually simplify this.
Turns out to be 4 root 6.
Yeah, so what I'm going to have to do is I'm going to have to simplify the square root of 24 and see what it comes out to be. And if I do have like radicals, then I go ahead and subtract them. All right, so what perfect square goes into 24? Remember your perfect squares. Hi.
It's going to be 4 and 6.
Yeah. So, here. You need one of these. There you are. Thank you. So, where's that listed? Oh, here it is. Right? I listed perfect squares. There they are in purple. 1, 4, 9, 16, 25, 36, 49, 64. Right? We're dealing with perfect squares here. So I want the biggest one that divides into 24, so it's got to be 4, right? 4 is the biggest one in this list that divides into 24. So, when I'm going to simplify the square root of 24, I break it up into the square root of 4 times the square root of 6. I know the square root of 4, it's just 2. So, just this chunk, the square root of 24, is 2 root 6. But that's not all that's going on. Don't I have this 2 times this in front of it? So what I really have is 2 root 6 minus, and I'm doing 2 times 2 root 6, which is 4 root 6. So now that I've simplified that square root of 24, I can see I actually do have like radicals. I have 2 root 6 minus 4 root 6, so my final answer would be, what's that final answer? Someone's mumbling it. Negative 2 root 6 is right. Right? Because aren't I just doing the operation on the coefficients? 2 minus 4, negative 2. And leave that root 6 alone. Does that make sense?
So for subtracting, it's the same thing.
Yep. As long as you have like radicals, you just add or subtract like you normally would.
What
Yep.
if you don't have
Where did the 2 go that was in front of like the square root of 24?
So I got multiplied by that 2. So 2 times 2, that's how I got the 4 root 6. So the other question was, what happens when you don't have, like say I had the square root of 2 plus the square root of 3. There's no simplifying to be done. There's nothing I can do there. That's as best as I can do. It's like trying to add x plus y. Well, that's my answer, x plus y. Same thing here. They're not like radicals, so if I want to add them together, that's how I do it. I just leave them as they are. But you always have to check if there's something that can be simplified, I have to simplify it. Because I may end up with like radicals. So let's look at 13 is a good one.
What if there's 2 like radicals and then 1 not?
Then I would only add the 2 that are like together.
And then
The other one would just stay. Yep. We'll do an example in a minute. So let's look at 13. At first glance, they are not like radicals because one's a root 8 and one's a root 2. However, you realize, oh, wait a minute. 8 has a perfect square factor, doesn't it?
Yes.
Yeah, so this will break up into the square root of 4 times the square root of 2. So it becomes 2 root 2. Don't forget about that 3 that's in front. So this whole thing is really 6 root 2. And then I want to add to it 3 root 2. So now you're like, oh, okay, I do have like radicals. And now I can easily add them together to get my final answer of 9 root 2. Is that all right? Try 10.
So if the 2 in the middle, like inside, if it was a 2 and like a 3,
Hold on. Go back. Where do you mean?
like at
This
the
one?
bottom, yeah,
This one?
yeah, there's how there's 2 2s in there. So if there's like a 2 and a 4, they could be 6 or
No. If these aren't the exact same, the square roots, you can't add them together.
so then would you take like the higher one?
You just leave it. So for example, if it was 6 root 2 plus 3 root 5, right? And you're trying to add that together, that's your answer. You can't, that's exactly how you'd write it. You can't get any more combined than that. You just leave it. Okay, so working on 10. Okay, we got an answer?
11 root 6.
All right, so square root of 54 is going to break up into 9 and 6. Correct. The square root of 9 is 3, but I have this 3 from the front, so that chunk right there will be a 9 root 6. Does everybody agree? And then I'm going to add the 2 root 6 to it. So my final answer, I heard a bunch of right ones. 11 root 6 is right. Perfect. So, does this get harder? Yeah, it can if we throw in 3 terms. Oh, sure. So, before we get to that, let's just check out 11 real quick. So, this one just has a negative in front. That just means my answers for this chunk is just going to stay negative. So, the square root of 12, I'd split that into 4 and 3, right? So, I get 2 root 3. So, what happens with this negative? It just comes right down. So, it's really just a negative 2 root 3 plus 3 root 3. I have like radicals, So when I add those two together, what's left over? Thank you. Positive 1 root 3. And since it's just a 1, I don't need to write it in the front. If I don't want to, you can. It doesn't matter. Just square root 3. Okay, let's try one with 3. First, let's look at one like number 20. Is there any simplifying to do here? No. All of these radicals are fully simplified. I know you might be thinking about 6, but 6 only has factors of 2 and 3, and they're not perfect squares. So, all of these are totally simplified. When I go to combine like radicals, they're not all like radicals, but this one and this one are. Right? Because they're both root 5s. So, what am I going to do? I'm going to combine those two, and then that one just stays as it is. Right? It's like trying to add x plus y plus x. Well, can't I just add the two x's together and then have the plus y on the end? Yeah, it's the same idea. So, what do I get when I add negative 3 root 5 minus root 5? Negative 4 root 5. And then that minus root 6 just stays. Doesn't matter which one comes first. Actually, no. So if you had written your answer as negative root 6 minus 4 root 5, same thing. Doesn't matter. So either one. So that's actually a good thing to remember if it's multiple choice. It doesn't matter which term comes first. There's not any kind of rule. There is a rule if you have an integer and a radical. So let's say your answer was something like, I don't know, 3 plus the square root of 6. You would always see it written that way, and almost never would you see square root of 6 plus 3. So when you have a regular number, that always goes in front. Radicals are always supposed to go at the end. In this case, since they're both radicals, how can I put both of them at the end? You can't. But if I only have one radical, that one radical is supposed to go at the end. Does that make sense? All right. Okay. So now let's step it up and let's try 3 that aren't necessarily all simplified. Like, I don't want to start you off too hard. How about, thank you. I guess 21. Try that one. So here, how many of these will simplify? 2 of those need to be simplified. So take a moment and try that. Okay, how'd we do? Everybody came up with something? Alright, let's try it. What do I do with this negative 3 root 2? Nothing. 3 root 20. Alright, 20 needs to be simplified. 4 and 5, so I get 2 root 5, but don't forget there's really this 3 times 2 root 5. So that whole chunk really becomes 6 root 5. You got it. Uh-oh, square root of 8. That needs to be simplified as well. 4 and 2. So I get 2 root 2. There's still this minus 3 really in front. So, isn't that going to be a minus 6 root 2? Right, when I put it all together? And then let me just drop down this thing from the beginning. Negative 3 root 2 plus that. Okay, so now here is my problem fully simplified. Well, all my radicals simplified anyway. Now let's combine like radicals if I have any. Do I have any? Yes, the root 2's. So when I put them together, I'm going to get negative 9 root 2. You got it. And then I just have that plus 6 root 5. Again, if you have your answer as 6 root 5 minus 9 root 2, same thing, it doesn't matter. I'll get there. Thank you. Thank you. All right, so do you want to try some of these on your own?